Hello viewers, welcome to my YouTube channel. In this video, we are asked to find all complex numbers of z such that 3z plus 1 times 4z plus 1 times 6z plus 1 times 12z plus 1 equals to 2. Okay, so without wasting much time, we are going to start solving this problem. So before I proceed, I would love you to subscribe to my YouTube channel and click on the notification icon for updates on my videos. Okay, so now let's go ahead and solve this problem. So the first step is for us to make these terms that have this coefficient of z. These terms, we want to make them to be equal. Okay, so what we are going to do is we are going to multiply each of these terms with a number. Okay, in this case we are starting with 8, so we are going to use 8 to multiply 3z plus 1, and this will be followed by using 6 to multiply 4z plus 1, and this will follow by using 4 to multiply 6z plus 1, and we are also using 2 to multiply 12z plus 1, and this will be equals to 8 times 6 times 4 times 2 times 2. This one is this 2 here. Okay, so let's multiply everything out. We're gonna have 8 times 3z. This will give us 24z plus 8. Then we have 24z plus 6. Then we have 24z plus 4. Then we have 24z plus 2, which is equals to 768. Okay, so now if you notice, we have 24z here, we have 24z here, we have 24z here, and we have 24c here. Okay, so the next thing is for us to equate this to a particular constant. So let's say let a equals to 24z plus 5. Okay, if we do this, we're going to have difference of two squares at the end, so just watch out. So if a equals to 24z plus 5, and here we have 24z plus 8, so we're gonna end up having a plus 3. Okay, because a on its own is 24c plus 5, and if we add 3, we're going to have 24c plus 8. Okay, so here we're going to have a plus 1, and here we are going to have a minus 1, and here we are going to have a minus 3, which is equals to 768. Okay, so the next step is for us to rearrange this. Okay, let's rearrange in order for us to have difference of two squares. Okay, so we're gonna have a plus 3 and a minus 3. Okay, and we're gonna have a plus 1 and a minus 1 equals to 768. Okay, so we can expand this. Let's multiply this out. This will give us a squared minus 9. Okay, and this will give us a squared minus 1 equals to 768. Okay, here we have a squared and here we have a squared. We can say let a squared equals to b. Okay, so this will give us b minus 9 times b minus 1 equals to 768. Okay, so let's continue on this part of the board. If we expand this bracket, we're going to have b squared minus b minus 9b, okay, plus 9 equals to 768. Okay, so this will give us b squared minus 10b plus 9 equals to 768. Okay, if we take over this to this side, we're going to have b squared minus 10b plus 9 minus 768 equals to 0, and this will give us b squared minus 10b minus 759 equals to 0. Okay, so this becomes a quadratic equation, and we are going to solve this using factorization method. So what we are going to do is we need two numbers that when we add, we're going to have negative 10, and when we multiply, we're going to have negative 759. Okay, and the two factors are negative 33 and positive 23. Okay, so let's continue on this part of this board. And if we substitute these two factors, negative 33 and 23, into this equation, we are going to have b minus 33 and b plus 23 equals to 0. Okay, so if we equate each of these, we're going to have b minus 33 equals to 0 and b plus 23 equals to 0. Okay, so therefore b equals to 33 and b equals to negative 23. Okay, but recall, let me write here, recall that a squared is equals to b. Okay, I've written it down here already. So this was one of the conditions that we used. A squared equals to b. Okay, if a squared equals to b, if we consider 33 first, that means a squared equals to 33 and a equals to plus or minus square root of 33. Okay, in the same vein, if we consider a squared to be equals to negative 23, that means we are considering this one now. That means a equals to plus or minus square root of 23i. Okay, because we need to include the imaginary number because it's negative, so we have plus or minus square root of 23i. Okay, let's continue on this part of the board. That means the two values of a are this and this. Okay, let me write it here. The two values of a are a equals to plus or minus square root of 33 and a equals to plus or minus square root of 23i. Okay, so now let's recall, let me write here, recall again, that a is equals to 24z plus 5. Okay, if we replace a with 24c plus 5 in this equation, you're gonna have 24z plus 5 equals to, let's take this first one, plus or minus square root of 33. Okay, and c on its own will be plus or minus square root of 33 minus 5. This positive 5 will cross over and changes to negative 5 divided by 24. Okay, this is for the first value. Let's do the same here, and this one will give us, so let me draw a line. So this one will give us 24z plus 5 equals to plus or minus square root of 23i. Okay, then z on its own will be equals to plus or minus square root of 23i, okay, minus 5 divided by 24. Okay, so these are the complex numbers of z. Okay, these and these. All right, so right now we have come to the end of the class, and if you think that there is another method of solving this problem, kindly drop it on the comment box, and please don't forget to subscribe to my YouTube channel and click on the notification icon for updates on my videos. Thank you and goodbye.